Hello, welcome to our first lesson in mathematics, particularly algebra. Our lesson today is all about sets. We will be dealing with universal sets, empty set, subset, proper subset, also the operations involving sets like union, intersection, and complement. Let's talk about terminologies in sets. So the first is the universal set. It is usually denoted by this symbol. And when we talk about universal set, it is a set of all possible elements of a certain problem. Like for example, let the universal set be all integers, or let the universal set be all whole numbers. When we say whole numbers, that starts with 0, 1, 2, 3, and so on. Now, let's talk about empty set. Empty set is denoted by these symbols, and it is a set containing no elements. For example, we are looking for a set containing all integral solutions of the equation x squared equals 5. Now, if we solve for the value of x, we will have plus or minus root of 5, which are both not integers. Therefore, our set A will be an empty set. Next, we have subset. A subset is denoted by this symbol. If every element of set A can be found in set B, then we say that set A is a subset of set B. Let's have this example. Let's say that set A has elements 1, 2, 3, 4, and set B has elements 1, 2, 3, 4, 5. Since all elements of set A can be found in set B, therefore we can say that set A is a subset of set B. Next on our list is the proper subset, which is denoted by this symbol. We can say that set A is a proper subset of set B if set A contains all the elements that can be found in set B. Yes, we can also say that proper subset is a subset, but the difference is for the proper subset, we are not including a set that contains exactly all the elements from one set, meaning set A is not equal to set B. To make it clearer, let's have an example. Say that we have A with elements 1, 2, 3, 4 again, and set B with elements 1, 2, 3, 4, 5. Now, since all the elements from set A can be found in set B, we can say that set A is a proper subset of B, or set A is a subset of B. Meanwhile, on this example here, we can see that all elements in set A can exactly be found in set B. Therefore, set A is not a proper subset of B. We can only say that set A is a subset of B. Any questions? How are we going to determine the number of subsets or proper subsets? Well, we can use these formulas. For the subset, we're going to use 2 raised to n. For the proper subset, you will use 2 raised to n minus 1, where n is the number of elements. Why is there a need to subtract 1 to get the number of proper subsets in a given set? That is because we are excluding a set which contains exactly all the elements of one set to another set. Let's have an example. Say that we have set A with elements 1, 2, and 3. Now we are going to identify the number of subsets and proper subsets in this set. We use the formula 2 raised to n to identify the number of subsets. So you just substitute the variable n by its value, which is 3. So we have 2 raised to 3, which when you simplify becomes 8. Let us list down all the subsets. Take note that empty set is always a subset of any set. That is always included. So we have empty set 1, 2, 3, 1, 2, 1, 3, 2, 3, and 1, 2, 3. Let's move to identifying the number of proper subsets in set A. We use the formula 2 raised to n minus 1. And again, just substitute the variable n by its value, which is 3. So we have 2 raised to 3 minus 1. That becomes 7. Compare the results that we just got. For the proper subsets, there is no set containing the elements 1, 2, and 3, because that is exactly the same with the given set, which is set A. Last on our list is the cardinality. It is usually denoted by this symbol. The cardinality of set A, which can be written as this, is the number of distinct elements in set A. For example, let A be the set of letters in the word review. Then, since we are dealing with cardinality, there must be no repeating elements. Therefore, the cardinality of A is 5. Let's move on to operations on sets. First on our list is the union. It is denoted by this symbol, and the elements of two sets are combined. Say for example, we have set A with elements 2, 3, 5, and 7, and set B with elements 3, 5, 8, and 9. Then, the union of two sets has elements 2, 3, 5, 8, and 9. Take note that the elements must be distinct. Next example, if set A contains negative 2, 0, 2, 4, and set B contains negative 1, 1, and 3, then the union of A and B is equal to the set negative 2, negative 1, 0, 1, 2, 3, and 4. Next, we have the intersection. It is denoted by this symbol, and it is a set with elements common to both sets. For example, if set A has elements 2, 3, 5, 7, and set B has elements 3, 5, 8, and 9, then the intersection of A and B is the set 3, 5. Take note that 3, 5 are the numbers present in both sets. Next example, if set A contains integers less than 2 and set B contains integers greater than negative 2, then the intersection of two sets is the set containing the elements negative 1, 0, and 1. Last is the complement. It is denoted by these symbols, and it is a set of all elements that are not in a certain set. For example, if set U contains 2, 3, 5, 7, and set B contains 3 and 5, then we say that the complement of B is the set containing 2 and 7. In other words, the elements that are not present in set B but can be found in set U are 2 and 7. Next example, if set U contains all real numbers and set B contains real numbers less than 10, then what do you think is the complement of B? Well, the complement of B is the set containing real numbers greater than or equal to 10. Did you have the same answer with me? Let's have our practice exercises. You will be given 5 items for 30 seconds each. Are you all ready? Okay, let's have our first question. If U is the set of letters and examine, which of the following is always true? A. The cardinality of U is 7. B. The number of proper subsets of U is 64. C. The number of subsets of U is 128. Or D. The elements in the set U are distinct. The correct answer is letter D. The elements in set U are distinct. We cannot choose A because the cardinality of U is 6 and not 7. Take note that an element of a set must not repeat. Letter B is not the answer because the number of proper subsets of U is not 64, but instead it's 63. Letter C is not also the answer because the number of subsets of U is not 128. It's very big. It must only be 64. Second question. Let X be a set. If the cardinality of X is 5, How many subsets are there with at most 4 elements? A. 31, B. 30, C. 21, D. 20. The correct answer is letter A. 31. Since you're looking for the number of subsets with at most 4 elements, it includes empty set with exactly 1 element, sets with exactly 2 elements, 3, and 4. Since there is only one set containing exactly 5 elements, we have to eliminate that. So you identify the number of subsets first. So that's 2 raised to 5, which is equal to 32. Since there is only one set with exactly 5 elements, 32 minus 1 gives you 31. You don't have to list down empty set 1, 2, 3, 4, and so on. You are only given 30 seconds, so make the best out of your time. Next question. If Z is a set of even numbers and Y is a set of odd numbers, what is Z intersection Y? A. Set of even numbers. B. Set of odd numbers. C. Set of prime numbers. Or D. Null set. The correct answer is letter D. Null set. Since there is no intersection between the two sets, our answer is null set. Let sets P and R be subsets of set Q. If Q has elements 1, 2, 3 up to 11, set P has elements 5, 6, 7, 8, 9, and set R has elements 9 and 11, find the complement of P union R. A. 2, 8, 7, 3, 4. B. 1, 4, 10, 3, 2. C. 9, 1, 4, 3, 2. Or D. 3, 10, 11, 3, 1. The correct answer is letter B, the set containing 1, 4, 10, 3, and 2. Since the union of sets P and R contains the elements 5, 6, 7, 8, 9, and 11, we have to look for its complement. Since we know that sets P and R are subsets of Q, we have to look for those elements which are not present in their union. And those numbers are 1, 4, 10, 3, and 2. Last question. If set W contains 3 and x minus 3, set R contains 2x and x plus 1, and the intersection of those two sets is equal to negative 6, find the elements of set R. A. Negative 6 and 3. B. Negative 6 and negative 3. C. Negative 6 and negative 2. D. Negative 6 and 2. The correct answer is letter C, negative 6 and negative. Take note that in the problem, the intersection of W and R is equal to negative 6. Therefore, it is just right to conclude that one of the elements of W, which is x minus 3, must be equal to negative 6. To find the value of x, you just equate the two. That is, x minus 3 equals negative 6. Simplify, you will get x equals negative 3. To find the values or to find the elements in set R, just plug in negative 3. That becomes 2 times negative 3, which is negative 6. And then negative 3 plus 1 becomes negative 2.